The PRACH is time and frequency multiplexed with PUSCH and PUCCH. PRACH time frequency resources are semi-statically allocated within the PUSCH region, and repeat periodically. The PRACH occupies 6 PRBs in the frequency domain and in time domain occupy 1, 2 or 3 subframes, depending on the specific preamble format. The preamble is a burst, which consists of a TCP, cyclic prefix, thus allowing for an efficient frequency domain receiver at the E node B. And a sequence. The preamble length is shorter than the PRACH slot in order to provide room for a guard time to absorb the propagation delay. The guard time is required since the E node B does not know when the preambles will arrive. An example with 2 UEs. The UEA is next to the E node B, therefore there is very little delay. In contrast, UEB is some distance from the E node B, as such the initial access preamble is delayed. There is a round-trip delay. The E node B must allocate a large enough window such that the preambles from UE at the edge of the cell don't arrive outside of this window. In LTE there are 4 possible preamble format configurations possible. The formats can have either short or long cyclic prefix, CP. The long CP, used in formats 1 and 3, enable an increased tolerance for timing uncertainty. By aggregating 2 preamble sequences, as done in formats 2 and 3, there can be better compensation for path loss, which also means that these 2 formats are better for cells of large radius. There are 5 preamble formats in LTE. Each format is defined by the durations of the sequence and its CP. The formats are designed to enable efficient operation in different scenarios. For example, the varying length of CP can be used to counter either small or large delay spread effects due to the mobile's position. For format 0, 1 millisecond random access burst with 800 microseconds preamble sequence, for small to medium cells, up to 14 kilometers. Format 1, 2 milliseconds random access burst with 800 microseconds preamble sequence, for large cells, up to 77 kilometers, without a link budget problem. Format 2, 2 milliseconds random access burst with 1600 microseconds preamble sequence, for medium cells, up to 29 kilometers, supporting low data rates. Format 3, 3 milliseconds random access burst with 1600 microseconds preamble sequence, for very large cells, up to 100 kilometers. Format 4 is only available for LTE TDD, frame structure type 2 and special subframe configurations, for small cells, up to 4 kilometers. The preamble format is specified by the cell preamble FMT parameter, and the cell radius is specified by the cell radius parameter. The maximum number of preamble available per cell is 64 preamble generated by Zadov-Chu sequence. There are multiple root Zadov-Chu sequences used in LTE. From each root sequence, multiple preambles can be obtained by applying different cyclic shifts. An example of 2 UEs, UE1 at cell edge and UE2 close to the E node B. The cyclic shift used by UE1 is 0 and the cyclic shift used by UE2 is NCS. At the E node B, the observed cyclic shift of UE1 will not be 0 but some value x because of the transmission delay. As long as x is less than NCS, the autocorrelation between the shifted x and shifted NCS, as perceived by the E node B, will be 0, and the E node B will be able to distinguish between the accesses from UE1 and UE2. So, the maximum cell radius is limited by the cyclic shift. The calculation of the maximum supported cell radius by a cyclic shift, NCS, is as follows. The preamble sequence length is 839 and spans 800 milliseconds. So, to keep the NCS value larger than the transmission delay, the formula is NCS multiplied by 800 microseconds and divided by 839, should be larger than the sum of the round-trip delay and the delay spread. The round-trip delay is equal to time of the cell radius divided by c, the speed of light. From the formula, The maximum cell radius shall be less than the NCS value multiplied by the preamble sequence 800 microseconds divided by 839 minus the delay spread, multiplied by the speed of light and divided by 2. The preamble is generated by Zadov-Chu sequence, where NZC is the total number of Zadov sequence, equal to 839 for preamble format 0, 1, 2, and 3. For preamble format 4, NZC equal to 139. The parameter U is derived from the root sequence index parameter used to generate the RACH Zadov-Chu sequence. The mapping between the logical root sequence index and the physical value of U is determined by the following table. The first column for the logical value root sequence index, and the second column for the physical value of parameter U. For example, if the root sequence index is equal to 122 in the range of 116 to 135, then the mapping of 122 from the table to the value of U is 37. Now, the generation of 64 preambles from a single base sequence is given by a cyclic shift defined by the zero correlation zone config and high-speed flag parameters. The mapping between zero correlation zone config and the cyclic shift NCS is determined by the following table. The first column is the zero correlation zone config parameter and the second column is the NCS value. The unrestricted set is for high-speed flag equals to false and the restricted set for high-speed flag equals to true. For example, the zero correlation zone config parameter equal to 9, and the high-speed flag is false, then the NCS value is equal to 59. The maximum number of cyclic shift that can be used is from 0 to NZC divided by the NCS value -1. In our example, the NCS value is 59, then the number of cyclic shift is from 0 to 839 divided by 59-1 that equal 13, so a total of 14 cyclic shift that can be used for the first generated sequence 37 in our example. So, to generate the 64 preambles, we need more Zadov-Chu sequences, calculated as follow: 64 divided by 14 is equal to 4.5. Then we need 4 more Zadov-Chu sequences. In our example, the first sequence is 122, the next will be 123, 124, 125 and 126 root sequence index, that will be reserved for only one cell. Then the 64 preambles are generated as follow for our example. The first preamble will use the base sequence, U37. The second preamble equals cyclic shift to base sequence by 1 times 59. The third preamble equals cyclic shift to base sequence by 2 times 59. Till 14th preamble. RACH sequence, 13, equals cyclic shift to base sequence by 13 times 59. Then, to use the next root sequence index, 123, and the value of U is 802. To generate the next 14th preambles. The set of zero correlation zone values for preamble format 0 to 3 is presented in the following table. With the high-speed flag setting when it's set to false and true, with the required number of root sequence index required per cell for each NCS configuration and the maximum cell radius supported by each NCS value. If the cell range is 5 km, and the high-speed flag is set to false, then the NCS value is 8, and the number of required root sequence index for the cell is 4. If the cell range is 10 km, and the high-speed flag is set to true, then the NCS value is 9. And the required number of root sequence index for the cell is 7. The UE receive the parameters to generate the 64 preambles, in System Information Block Type 2. In RACH configuration setting as follow: root sequence index, high speed flag, and the zero correlation zone config.